class. I wanted to go over the kind of theory of the atom and how that has morphed over time. And this is a good thing to keep in mind because a lot of times we make a educated guess or a scientific prediction based on the information we have, and then information changes, and so our answers change. So that's just something to keep in mind. That a lot of times it's okay to have wrong answers because they could be right at the time. So today I'm just going to go over like these two, and then I'm going to set you up for how to do the activity for getting to this model. Okay. So Democritus was an old Greek philosopher, and he came up with the kind of original idea of the atom. So you're talking 5th century BC, and he thought all matter is composed of small invisible particles called atoms. And that's kind of all, it wasn't scientific, it was really more theoretical because he was a philosopher. And although he was definitely on the right track, most people of that time did not accept that as the best answer because he wasn't the most popular philosopher. It's funny how popularity comes into some of this, right? Aristotle was the popular philosopher, and he had this idea here that the main elements were earth, wind, rain, or water, and fire. So he was the one that was kind of believed because he was popular, even though Democritus was much more probably close to what was the truth. And then fast forward to 1800s, and John Dalton came up with a kind of atomic theory of his time. The atoms are invisible or indivisible, meaning they can't be broken, and compounds and combinations of different types of atoms. So this is called, the nickname is kind of the solid sphere model. The idea, this is almost like the nickname is sometimes the pool cue ball, that it's completely solid. It's not like there's like a hole in it where there's like a missing whatever, that like if this is an atom of gold, let's say, the whole thing is gold. It's all just gold, gold, gold. If it's iron, it's all iron, iron, iron. So that was kind of his model. And there were some scientific tests that he did, very simple tests that he did, like cutting down a piece of gold and it was still gold, 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 gold until he couldn't cut it anymore, that kind of idea. So kind of simple science. So that is where we're going to go into our first investigation today. And you're going to be using this Google form, which has the link in it. Okay. So I'm going to kind of show you how to do this. So remember that as of this right now, we think that the atom is a solid sphere, right? We're at Dalton's model, and this is he's kind of testing that assumption. If it's a solid sphere, there should be nothing inside it, no positives or negatives or whatever, nothing that would like distract a particle from being shot through it. And so this is a very simple version of this. But you have a couple choices. You can do a beam or a particle. I'm going to start with the beam now. You can definitely play around with it. And I'm going to start it where there's no charges on these plates. Okay. So I'm going to turn on the volt, and we can see that this, you don't have to worry about the nitty gritty of like what's being shot through here or anything like that, but we can see that it's going straight through. And this is the expectation. If we're shooting something at a solid material that's all the same throughout the solid material, we shouldn't see any change from this. So then what they did, and you can play around with this, they have silver, they have gold, and they have iron. You can play around with these as well. They went ahead and they put plates on it that had a charge, kind of like a magnet almost. And so you're observing here what's happening to the particles that they're sending through. Okay. And then you can change this and see if anything changes with the substance that you're using. Does it make any difference whatsoever in what's happening? And so that's what you're doing in this activity. You're filling out this Google form. So turning on the machines, choose silver, and then you're gonna move to the bottom left side of the bar, move the circle on the bottom left side of the bar. So what I mean by that is like you're gonna move it all the way over here like this, and you're seeing what's happening to, in this case, the green substance, and you're answering these questions. Does the green substance go toward the positive plate, toward the negative plate, or does it actually stay straight through? So just kind of answer these questions based on the directions and what you think is going on with the model. So that's it for today, and then we'll talk about what that means in our next video.